field at a point due to multiple charges. Field at a point due to multiple point charges. Multiple point charges. It means number of charges are placed at different points in the space. All are not spaced at the origin here. Different points in the space, and all the charges produces a single field at a point by the superposition principle. The individual fields of individual charges superposes at that point and produces a single field. That field is called resultant field. All the charges produces its individual fields at a point if the number of point charges are placed in the space. At a particular point, the charge q1, q2, so on, for example, q1, q2, so on, qn are the n point charges placed in the space at different points. And each and every charge produces its own field at a point P, say. Then all the electrical field superposes to produce one single field at that point. That single field is called resultant field. And what is the expression for that? Resultant field produced by multiple charges. Means more than one charge is there. Then all the charges combinedly produces one single field at that point. That is the resultant field. What is the expression for the resultant field? We are going to get an expression for it. Okay. Let q1, small q1, q2, small q2, small q3, so on. Qn are the n point charges. Are the n point charges. Point charges. Here mind that one, all are not placed at origin, are placed in the space at the points where here in the single charge case we have taken the single charge capital Q is placed at origin, but here is Q1, Q2, Q3, so on up to Qn, capital Q is not taken. Here the source charges are taken as small q1, are placed not at the origin, are placed at the points where the position vector of those points are placed at the point whose position vectors are, Q means position vectors are, it is R1 bar, R2 bar, R3 bar, so on to Rn bar. Okay. Now I would like to calculate what is the field at the point P, whose position vector, the point P, the position vector of the point P is R bar, means OP bar is R. P is a point in the space. P is a point in the space whose position vector is, P means position vector is OP bar is equals to R bar. E bar is the, by the superposition principle, all the fields of all the charges here it is respectively is to be taken. Okay. Fields of all the charges that is E1 R1 bar, simply let us call it as E1. Okay, E1 is enough, comma E2 bar, comma, E3 bar, so on to En bar superposes means combines at the point P, produces a resultant field E bar of R bar, because the position of the point P, OP bar is R bar. The field at that point is E bar, and it is given by E1 E bar R bar is equals to E1 bar plus E2 bar plus E3 bar plus 1 to En. Okay, plus 1 to En bar. Where E1 bar? What is the E1 bar? Let us take the diagram. I will complete this expression now. So it is the superposition principle. No? If the number of vectors P bar, Q bar, R bar are acting at a point, then the resultant vector R bar is equals to P bar plus Q bar, as we did last year. Okay. Here, look here. Here is the point origin O, and here is the charge. Origin O is not necessary. Actually, specifying the origin O is not necessary. Here the charge Q1 is placed. Here the charge Q2 is placed. Okay. Here the charge Q3 is placed, and here is the point P, say. So this is the distance between the point Q1 and P is R1P. Okay, and distance between these R2P. Distance between the point P and the charge Q2 is R2P. Here Q1, Q2, Q3 are the source charges or the test charges here. The distance between R3 and the point P is R3P. Okay, the charge Q1 produces the field E1 bar, and charge Q2 produces the field E2 bar at the point P is E2 bar. The charge Q3 produces the field E3 bar. Okay, E3 bar. Actually it is E1 of R bar, because the position of this charge Q1 is R1 bar. Therefore E1 of R1 bar, E2 of R2 bar, E3 of R3 bar, like that. Okay, enough. E1 bar is enough. E1 R bar and so on is not necessary. Okay. Now, what is the field due to the charge Q1 at the point P? It is by the individual charge, single point charge. The formula is 1 upon 4 pi epsilon naught. The charge is Q1 upon distance is R1P into R1P cap, where R1P cap is the unit vector in the direction of R1P bar, plus these are all the individual point charges. The E1 bar, E2 bar, E3 bar, En bar are the field due to the individual charges Q1, Q2, Q3, Qn respectively. Okay, here it is given now. It is 1 upon 4 pi epsilon naught Q2 upon R2P into R2P cap, the magnitude of the field, and it gives the R1P cap in the unit vector in the direction of R1P bar. Okay, R2P cap plus 1 to the nth charge field is En bar is 1 upon 4 pi epsilon naught. E3 bar is not written. Understood? E3 bar is 1 upon 4 pi epsilon naught. Charge Q3 upon R distance R3P into R3P upon R3P square. Here R1P square should be taken square of the distance, no, 1 upon 4 pi epsilon naught Q upon R square into R cap. So it is R2P square, and it is 1 upon 4 pi epsilon naught the charge Q1 upon R NP square or NP square into R NP cap. Okay. into r in p cap. So this is the magnitude of the field E1 bar, means U1 is equal to 1 upon 4 pi epsilon naught Q1 upon R1 p square, where R1 p is the distance between the charge Q1 and the p. So it is the field due to a single point charge is like that, no, at a point p, which is at a distance of r from the charge q, U1 upon 4 pi epsilon naught, the charge upon the square of the distance between the point and the charge into unit vector in the direction radially, means unit vector r cap, where r cap is in the direction of along the radial direction, okay, means along the line join of the point and the charge. So Rn cap, in short I can write it as, therefore E bar R bar is equal to, I will complete that diagram later on, that is E bar of R bar, in short I can write it as 1 upon 4 pi epsilon naught is common for R. In summation notation I can write summation I running from 1 to n, it is Qi divided by Ri p square into Ri p, okay. Ri p cap. I is running from summation I is running from 1 to n. In summation notation is written, you know that what we mean by summation notation. I is taken as 1, then it is Q1 upon Ri p square. Ri p square, it means R1 p square into R1 p cap, plus summation is plus. When Qi is 2, then it is Q2 upon R2 p square, R2 p cap. When I is 3, it is Q3 upon R3 p square, Ri p cap. R3p cap, which gives the direction, this gives the simply direction, with the magnitude actually. These are all the quantities written in the bracket are magnitudes, and this last one Rip cap gives the direction of the finger, okay. Where, this is the final formula, where Rip is the distance between the charge Qi, and the point P. And Rip cap is the unit vector in the direction of Ri p bar. Actually, unit vector gives the direction of the individual field. So actually this E1 bar is in the direction of R1 p bar. It is in the direction of E2 bar is in the direction of R2 p cap, okay. R2 p bar or R2 p cap are both in the same direction. This is the vector R bar, and its unit vector is R cap. Both are in the same direction. Understood? This is the superposition principle. Actually, this by this theory you can't solve the problem. By solving the problem, you have to use some additional technique. So even though it is E1 bar plus E2 bar, resultant field is E1 bar plus E2 bar plus E3 bar plus 1 to En bar. So you can't add it algebraically with the vector addition. For vector addition, first you have studied how to get the vector addition. First of all, you have to work out E1 bar and E2 bar. Okay. Then E1 bar and E2 bar results into a single quantities vector that say E1 dash bar set, that E1 dash bar is to be added with E3 dash bar, E3 bar, then those two combine to give one single vector. That vector should be added with E4 bar. Diagrammatically I will show it. So let us add the vector by law of parallelogram law of addition of vector. Let us use the parallelogram law of addition of vector. So all the n vector cannot be added algebraically. So pairwise vector is to be added. When pairwise vector is added, a single vector, that single vector is to be added with the third vector. So So like that you are getting a, by adding pairwise vector, pair two vectors, you are getting single vector. That single vector is to be added with third vector ultimately. So by pairwise addition you will get a single vector E bar. Diagrammatically I will show it. So this can be done with the help of using the law of parallelogram, law of addition of vector. Look here, E1 bar and E2 bar are the two adjacent sides of the parallelogram. You complete the parallelogram. Now this one gives actually the resultant of E1 bar and this is the diagonal of the parallelogram where adjacent sides are E1 bar and E2, E1 bar and E2 bar, E1 bar and E2 bar. E1 bar and E2 bar. E1 bar and E2 bar. And these E1 bar and E2 bar, the adjacent sides of the parallelogram. Parallelogram is completed and the resultant of E1 bar and E2 bar is given by the diagonal of the parallelogram. Let us call it as what? So it is E12 bar. Let us take it as simply E12 bar. Okay. Then E12 bar combines with E3 bar. So now E12 is the addition of E1 bar and E2 bar. E12 bar is the addition of E1 bar and E2 bar. Now it is E12 bar. E12 bar is added with E3 bar. So the E12 bar one vector, it is another vector. Again parallelogram is completed by taking these two sides. Okay. Complete the parallelogram by taking these two sides. One is E12 bar and another one is E3 bar at the adjacent sides and complete the parallelogram. Is it clear? The parallelogram is not clear. For this one, we draw a line which is parallel. This line is drawn parallel to this one and this line is drawn parallel to this one. This is the diagonal now. This is the diagonal of these two adjacent sides. This is the, actually this is the diagonal of what? This is the diagonal of this parallelogram. This parallelogram is obtained by taking E3 bar and E12 bar. E12 bar is the resultant of E1 bar and E2 bar. So this is the final, what it is, the field ER bar. I have taken for 3 charges, even though n charges are given. I have taken the diagram for 3 charges. By using the law of parallelogram of addition of vector, I can work out what it is. The addition of 3 fields E1 bar plus E2 bar plus E3 bar. E1 bar and E2 bar are added by using the law of parallelogram, and the resultant of those two is in the diagonal of the parallelogram. E12 bar I have taken till E12 bar. Then this E12 bar is combined with factorially added with E3 bar. It is E3 bar. This parallelogram is completed. Okay, this parallelogram is completed. This diagonal gives the addition of what? E1 bar plus E2 bar plus E3 bar. So it is ER bar. Okay. So this is the technique to add the vectors by using the law of parallelograms. But by solving the problem, this is not the technique. Actually, this is the only theoretical theory. But usually, while solving the problem, what you have to do is you have to work out. Just listen to me. You have to work out the magnitude of E1 bar and E2 bar. So, majority of the cases, addition of 2 fields will be there. When 2 fields are there, then you have to work out the magnitude of E1 bar and E2 bar. Okay. A magnitude, how to work out the magnitude 1 upon 4 pi epsilon. Magnitude of Q1 upon R1 p square, and the magnitude of E2 bar is 1 upon 4 pi epsilon into magnitude of Q2 upon R2 p square. Okay. Then by deciding the nature of the sign, you have to decide the direction. You have to decide the direction of individual field. You have to decide the direction of the individual field. Or, I'm sorry, so after working the magnitude E1 and E2 separately, then we can work out the magnitude of the resultant vector E bar by using the what? expression. So using the expression, E bar is equals to root of E is equals to magnitude E1 square plus E2 square minus 2 times of E1 into cos theta, where theta is the angle between E1 bar and E2 bar. So I will repeat. So I think you have got a little bit confusion. So while solving the problems, usually 2-point charges will be given. So not 10-point charges, 2-point charges problems will be there. I have worked out the resultant field of those 2-point charges. What to do? First of all, work out the magnitude of individual fields. E1 is equal to 1 upon 4 pi epsilon naught Q1 upon modulus of Q1 upon R1 P square. Okay. And E2 is what? 1 upon 4 pi epsilon naught magnitude of modulus of Q2. Modulus means only positive should be value of the charge should be taken, R2 P square. Then the magnitude of the resultant field is root of first year theory, root of E1 square plus E2 square minus 2 times of E1 E2 cos theta. So, and what is the direction of the vector, the resultant field E bar? The direction is given by an angle alpha. Alpha is equals to the tan inverse of E2 sin theta upon E1 plus E2 cos theta. It is not. This is the first year theory, how to work out the resultant of two vectors E1 P bar plus Q bar. R bar is the resultant of two vectors P bar and Q bar, means R bar is equals to P bar plus Q bar. Even though the theory says that R bar is equals to P bar plus Q bar, but you have to work out the magnitude of the resultant R separately and you have to work out the direction of the R separately. Direction is given by an angle alpha. The magnitude of the resultant vector R is equals to magnitude divided by R, where individual individual vectors magnitudes are P and Q. Then R is equals to root of P square plus Q square minus 2PQ cos theta, where theta is the angle between two vectors, and alpha is the direction of the resultant. And alpha is equals to tan inverse of E2 sin theta upon E1 plus E2 cos theta. Anyhow, I will recall this theory, first year theory, by taking not instead of taking E1 and E2, P and Q, taking E1 bar and E2 bar only. So just write down the note here. Note to work out the resultant of 2-point charges. To work out the resultant of resultant field of 2-point charges Q1 and Q2. Calculate E1 and E2 separately. Calculate E1 and E2, where E1 is equals to only magnitude is equal to 1 upon 4 pi epsilon naught. It is modulus of Q1 divided by R1 P square, and E2 is equals to 1 upon 4 pi epsilon naught modulus of Q2 upon R2 P square, where R2 P is the distance between the second charge Q2 and the point P, where at what point you would like to calculate the field, that is the point P. What is the point P here? At that point P, I would like to calculate the resultant field. Now let us consider the three cases. Case 1. If theta is the angle between E1 bar and E2 bar. Theta is the angle between E1 bar and E2 bar. Then E is equals to E is the magnitude of the resultant field. E is equals to square minus 2 times of E1 E2 cos theta. Okay, where E is the magnitude of the resultant field E bar, where E is the magnitude of the resultant field. The direction, even though theory says that E1 bar plus E2 bar like that, but you have to, while solving the problem, to find the resultant field with 2 point charges, you have to work out like this. You have to work out the magnitude of E1 and E2 separately, and then work out the magnitude of the resultant field. E is equal to root of E1 square plus E1 square plus E2 square minus 2 times of E1 E2 cos theta. The direction of E bar is given by an angle alpha, where alpha is equal to tan inverse of E2 sin theta upon E1 plus E2 cos theta. Okay, E1 plus E2 cos theta, E2 sin theta upon E1 plus E2 cos theta. Okay. Case 2. If E1 bar and E2 bar are in the same direction, this is the diagrammatically I can show like this. It is E1 bar and it is E2 bar. Even though the superposition principle says that E bar of R bar and E bar is the resultant field due to the n point charges is equal to 1 upon 4 pi sigma I is equal to running from 1 to n Qi upon Ri p square into Ri p cap. Then that is the theory. By solving the problems, this technique is to be used to work out the resultant field due to the 2 point charges. You have to work out the magnitude of the individual fields. So you have to work out the magnitude of the fields of the individual charges. Then the magnitude of the resultant field is like this, and the direction of the resultant field is like this. Case 2, if E1 bar and E2 bar, so this is E1 bar and E2 bar, so this is the what? E bar. This is the angle theta between the E1 bar and E2 bar. This is the resultant field E bar, and it makes an angle alpha with E1 bar. Okay, it makes an angle alpha with E1 bar. Case 2, if E1 bar and E2 bar are in the same direction, then E is equal to, very simple, E1 plus E2. Okay, pectorially dash. Why? In the same direction is theta is 0. Theta is 0 means automatically E1 square plus E2 square minus 2 times of E1 E2 cos theta. It is, or in the same direction. I am going to form it is not minus, it is plus. But it is plus. Sorry, it is not minus, it is plus. Okay, E1 plus E2. When theta is 0, when both are acting in the same direction, then E1 and E2 are in the same direction, is theta is 0. Look here, it is E1 bar and it is E2 bar. When the angle between them is 0, an angle between them is 0 means E1 square plus E2 square plus 2 times of E1 E2 cos 90, cos 0 E1. Therefore, E1 square plus E2 square plus 2 E1 E2 means E1 plus E2 the whole square. Square root of whole square is simply square root cancels E1 plus E2. And the resultant field E bar is in the direction of, in the same direction of E1 bar and E2 bar. So here is the point P6. bar is also in the same direction of E1 bar, and you can just E1 bar, E2 bar, and E are all in the same direction. Okay, here is the point P. Wherever it is, whatever. But here is the point P. Say, here is E1 bar. This is E2 bar. Okay. Now this is E bar. Case 3. If E1 bar and E2 bar are in opposite direction, this is the technique to solve the problem. Even though the theory says like resultant when E bar is E1 plus E2 bar plus E3 bar plus E4 bar plus En bar. So that is the theory only, but you can't work out the problem by that particular formula. So this technique is required to add the two fields vectorially. If you work out the magnitude separately, you work out the resultant field separately and direction separately. If E1 bar and E2 bar are in opposite direction, then theta will be 180. And cos 180 is equal to -1. Therefore, E1 square plus E2 square minus 2 times of E1 E2 is E1 minus E2 the whole square. Square root of E1 minus E2 the whole square is E1 minus E2. Then E bar is equals to E1 minus E2. Theta is only here, here is the point P. Here it is E1 bar and it is E2 bar. And therefore E is equals to, magnitude. We have to work out magnitude separately, we have to work out direction separately. While adding the two vectors, that is the technique. Even though the formula says that R is equals to R bar is equals to P bar plus Q bar, with the vector addition. This involves a pre-indication. You have to add the quantity vectorially. While adding the quantity vectorially, you have to work out the magnitude separately and you have to work out the direction of the resultant separately. Okay. So E is equals to E1 plus E2 and E is in the direction of and E bar is in the direction of which magnitude is greater, in the direction of, in the side of, or in the direction of greater of E1 and E2. Understood what I mean by greater of E1 and E2? If E1 is bigger, then the resultant is in this direction. Okay, E bar is in that direction. Okay, that E bar actually reduces. So it is not equals to E1. Not equals to E2, it is less than E1 and E2, okay, and they are in the opposite direction because subtraction will be there, no? E is 10, E2 is 9, then E1 minus E2 is 1 only, means the resultant field is able to smaller magnitude of the individuals. Therefore, so now it is E1, E is only this much, the length represents the magnitude, in vector always length represents the magnitude, smaller the length, then automatically smaller the length, then automatically smaller is the magnitude of that vector. Smaller the length of the line segment which represents that vector, and smaller is its magnitude. Okay, here is the case of E1 is greater than E2. If E1 is smaller than E2, means E2 is bigger, E2 bar is bigger say than E1 bar. Okay, greater length, smaller length. It means E1 is smaller here. E1 is smaller than E2. Then the resultant is coming in the direction of E2, but the resultant E is having the magnitude which is less than both E1 and E2 because E1 minus E2 is there, no? 10 minus 9 or 12 minus 6, the resultant is smaller than both 10 as well as 6, like that. It is E1 is 10, E2 is 6, then E1 minus E2 is 10 minus 6, that's equals to 10 minus 6, that's equals to 4, smaller than 10 as well as 6, is it not? You can put one modulus, better to put modulus because magnitude I told you magnitude is always positive. E2 is bigger, automatically E2 is bigger and automatically, so this magnitude will become positive. That's why magnitude is taken. But if E1 is bigger, then the resultant E is in the direction of E1. If E2 is bigger, then automatically the resultant E bar is here is the point P, right? Directed P at a point. E2 is bigger, then the resultant is in the direction of E2. The resultant E bar resultant is between the combined field of E1 bar and E2 bar is in the direction of E2 bar if E2 is bigger than E1. Okay, this is the theory. This theory is used to solve the problem. Actually, no need to mark all these points, just for the problem solution point of view, I have explained all these points. Okay, now let us take one problem. I will take one problem. Here is 2 point charges of magnitude. One problem we take, a good problem. Okay, good problem, examination point of view, good problem. 2 point charges. 2 PTs point charges. 2 point charges. Wait for a minute. Let's take problem. 2 point charges. 3 microcoulomb and minus 3 microcoulomb. 3 microcoulomb and minus 3 microcoulomb are minus 3 microcoulomb are located 20 centimeter apart in vacuum. Are located 20 centimeter apart in vacuum. VACCUM you can write, or VACUUM you write. Vacuum, what did we say? Vacuum, VACCUM or VACUUM. Vacuum 20 centimeter in or located 20 centimeter apart in vacuum. Okay. Question number A. What is the electric field? What is the electric field at the midpoint of, at the midpoint O, at the midpoint O of the line join of the charges. Line join of the charges. And second, this question number 2. If a negative test charge, if a negative test charge, if a negative test charge of magnitude 1.5 to 10 raised to minus 9 coulomb is placed at that point. Minus 9 coulombs is placed at that point. What is the force on this charge? What is the force? What is the force means what is the electric force? Okay. What is the force experienced by, what is the force on this charge? Okay. Means what is the force experienced by this test charge? Okay. With the help of the diagram, I will solve this figure. Sorry, I will solve this problem with the help of the diagram. Just take that. Okay. So here is the charge. One is 3 microcoulomb. Let us call it as charge QA. Placed at the point AC. That's why I have taken it as QA. Okay, placed at the point A. And its charge QA, how much it is? QA is equals to 3 microcoulomb. Micro means 10 to the power of, milli means 10 to the power of minus 3. Micro means 10 to the power of minus 6. And here it is point B. To the point B, another charge QB is placed instead of Q1 and Q2. I have taken QA and QB because so it is placed at the point A, therefore QA is placed at the point B, therefore it is QB. Any notation can be used to Q1, Q2, Q3 or QA, QB, QC like that. Okay, this is the line join of the charges. And what is the separation between them? 20 centimeters. Between A and B it is 20 centimeters. And here at the point O, O is the midpoint, I would like to get the resultant field. Put the field at the point O. The field at the point O is the resultant field due to the charge QA and QB. Okay. So now O is at a distance of what? 10 centimeter each. 10 centimeter each from the charge A as well as B. 10 centimeter. It is QB is minus 3 microcoulomb. Now, let us work out EA. EA is equal to EA is the understood. EA is the field due to the charge QE. EA understood now. So EA is the field due to the charge QA. EA is equal to 1 upon 4 pi epsilon naught. That is QA, the charge QA, upon distance between the point and the charge. The point O and the charge. I would like to get the field at the point O. Therefore, it is OA square of the distance. Even though theory says that R square are in the distance between the point. What is the point? Where you would like to work out the field. The point is that point where you would like to work out the field, and the charge A are in the distance between the point and the charge. Therefore, R square is the R square. OA square is taken one and the same now. Plus, it is R square root 2 that OA square is R square of the distance between the point and the charge. Okay. Now plus it is QA. 1 upon 4 pi epsilon naught modulus of charge should be taken. 1 upon 4 pi epsilon naught, you know that it is 9 into 10 raised to 9. Okay. Into QA. QA is 3 microcoulomb. Always everything should be in SI rate. While doing the calculation, it should be in SI rate, because this is 1 upon 4 pi epsilon naught is in SI rate. 9 into 10 raised to 9 is the SI value. Therefore, it should be in SI rate. Only charge also in SI rate. Microcoulomb is 10 to the power of minus 6 coulomb upon microcoulomb is equal to microcoulomb is 10 raised to minus 6 coulomb. Microcoulomb is 10 to the power of minus 6. Okay. Upon OA, OA is 10 centimeter. OA is equal to 10 centimeters. 10 centimeter in meter. 10 into centimeter is 10 to the power of minus 2. No, the whole square. Because centimeter is equal to 10 to the power of minus 2 meters. OA is 10 centimeter. Centimeter converted to meter. That's equal to 10 to the power of minus 2 the whole square. Now work out this quantity. 9 into 10 to the power of 9 into 3 into 10 to the power of 6. What it is, tell me? It is 10 into 10 to the power of 1 into 10 to the power of minus 2. Theory of indices. 10 raised to 1 minus 2 a raised to m into a raised to n is a raised to m minus n. It is 10 to the power of 1 minus 2. Sorry, a raised to m into a raised to n is a raised to m plus n, 1 minus 2, m plus n, m plus n, 1 minus 2, 1 plus of minus 2 is 1 minus 2, 1 minus 2 is minus 1, minus 1 the whole square. That's equals to 9 into 10 to the power of 9 into 3 into 10 raised to 6. What nonsense I am doing. So it is 10 to the power of minus 6. 9 3s are 27 into 10 to the power of 9 into 10 to the power of minus 6. It is 10 to the power of 9 minus 6. 3. 10 to the power of 9 minus 6. 10 to the power of 9 into 10 to the power of minus 6 is 10 to the power of 9 minus 6. That's 10 to the power of 3. A raised to m into a raised to n is a raised to m plus n. M plus n, therefore 9 plus of minus 6. Plus of minus 6 is minus 6. 10 to the power of 3 upon 10 to the power of minus 2 by minus 2. A raised to m whole raised to n is a raised to m into n minus 1 into 2. That's equals to 27 into 10 to the power of 3 plus 2. Why it is 3 plus 2? A raised to m upon a raised to n is a raised to m minus n. It is just because this theory is a raised to m into a raised to n is a raised to m plus n. Minus 2 goes to the numerator. Minus of minus 2 plus 2. Therefore, it is 27 into 10 raised to 5. What is the unit of field? Newtons per coulomb. Okay, newtons per coulomb. Now, EB bar. EB bar. So, EB, what is the magnitude I have got? Is equal to 1 upon 4 pi epsilon naught into magnitude magnitude of 2b divided by OB square. Everything is same. Everything is same. Magnitude of 2b is minus 3. It is 9 into 10 raised to minus 9 into magnitude of minus 3 into 10 raised to minus 6 meter coulomb. Upon it is 10 into 10 to the power of minus 2. Distance is same. Now OA equals to OB is equals to 10 centimeter. OA equals to OB midpoint means it is 20 means it is 10 and 10. The whole square. Let's say because modulus of minus 3 is plus 3 only. Okay, that's equals to modulus of 3. Modulus of plus 3 is 3 only. Modulus of minus 3 is also plus 3. Same is 27 into 10 raised to 5. Now, look here, both are in the same direction. Let us decide the direction here. Look here, get the positive charge, plus 3. Positive charge means A is in the, what it is, away from the radially outwards. The charge, this is important, when the charge is positive, the field at a point is radially outwards. Radially means along the line join of the point and the charge, radially outwards. Therefore, EA bar direction is outwards. Here QB is negative. When the charge is negative, the field is what? Towards the charge. The field is towards the charge only, radially inwards. Therefore, EB is towards the charge B and EA is towards the charge B from the point. The EB is the field at the point. It is the direction of EB is towards the charge. Why towards the charge? Radially inwards, means radially towards the charge. The charge is negative. And radially towards the charge from that particular point. Okay. Therefore, now EA is QA is positive. Therefore, its field EA bar is radially outwards, not inwards, away from the charge, along the line join of the charge and the point, along the line join of the charge and the point. Therefore, both are in the same direction. Therefore, the resultant field E, according to the case number 2, it is EA plus EB, is it not? Now, the resultant field E is equals to EA and EB are in the same direction. Therefore, EA and EB, EA bar and EB bar are in the same direction. Are in the same direction. Same direction. Are in the same direction. Therefore, E bar is 3 is equals to EA plus EB, where E is the resultant field. Where E is the resultant field. Where E is the resultant field of, where we need to write all these things, where E bar is the resultant field. Okay, resultant field. All these expressions are not necessary, whatever the things are written in the bracket, you need to write it in the examination. For your understanding sake, only all those things will be written. Okay. And therefore, E is equals to, it is 27 into 10 to the power of, how much I got? 27 into 10 to the power of 5. I think 27 into 10 to the power of 5 plus 27 into 10 to the power of 5. Okay, both are same. 27 into 10 to the, I might have not written EB. EB is also 27 into 10 to the power of 5 newtons per coulomb. Okay, work on that one. So I have simply written modulus of minus 3 into 10 raised to 10 to the power of minus 6 upon 10 to the power of minus 1 the whole square is written. But I have not completed the calculation. That calculation works out to be same. 27 into 10 to the power of 5. Okay. That's equals to what it is, 27 plus 27, 54 into 10 to the power of 10, 20 to 10 to the power of 5 common. Then what will it be? 27 plus 27 into 10 to the power of 5. That's equals to 54 into 10 to the power of 5 newtons per coulomb. Now okay, when both are in the same direction, the resultant field is also in the direction of E1 bar and E2 bar. The resultant field is towards, in the direction of OB.